Thank you guys for hosting me today. I'm really excited to be here. I am presenting tips and tricks for Next.js and Sitecore Headless. I did this presentation at SubCon North America um, back in October, it was, I think, now. And so happy to be doing it again to get it out to more people. I'm Corey Smith. I'm an independent consultant living in Atlanta, Georgia. I'm an 8-time Sitecore MVP with over 9 years of Sitecore experience. I'm a happy dad to a little toddler who's turning into a terrible 2. And I am also a lawn care and smooth jazz enthusiast when I'm not doing Sitecore. You can find me on Slack at Sitecore, and my website is corysmith.co. So please reach out on Slack anytime. Um, as you can see on my shirt, I am a co-host of Sitecore Lunch with my good friend and fellow MVP, Jim Patillo. So every Friday at 12:15 p.m. Eastern Time, 52 weeks a year without fail, we host Sitecore Lunch. It's a Zoom call that's open to anyone where we get together, we talk about Sitecore. A lot of times we talk very little about Sitecore and talk more about other things. We can always count on Bala to join us and ask questions about Sitecore if we go off topic too much. So if you're interested in joining us, we'd love to have you. I post the details in the general channel in the Sitecore Slack at 12:15 p.m. promptly every Friday. And if you're not on the Sitecore Slack, you can join it at the URL I've got shown there. Hope to see all of you at Sitecore Lunch on Friday. So our first tip is looking at the debug logging functionality in Sitecore's Next.js SDK. Sitecore's Next.js SDK, it comes with extensive debug logging functionality provided by an NPM package called debug. So when you enable this, you can get loads of handy debug information output to the server console and also to your browser. So this is really nice for debugging issues with your site. This functionality is hiding in plain sight in every Next.js application from Sitecore. To turn it on, all you have to do is open up the .env file of your application and uncomment this line right here. And what this will do is this will turn on the debug logs for all of Sitecore JSS's filters. You can be more selective. So instead of uncommenting this line, you could uncomment this line, for example, and this will only show layout service logs and it won't show the other ones. But you can even get more granular and instead uncomment out this line and this will show everything but the layout service logs. So it's really cool configurable functionality. One thing that you won't find in the env file that I recommend you turn on is this right here, debug multi-line equals true. So you add this environment variable to your env file, and this makes your debug logging a lot more readable. So this is the difference. If you don't set debug multi-line equals true, your server console will look like this when you turn on debug logging, but with multi-line set to true, it looks like this. It's a lot more parsable. So yeah, just take note of that if you're going to use this feature. I always turn that on when using debug logging. I talked before about debug filters. So this is an exhaustive list of all the filters that are available to you. Of course, if you want to see all the filters at once, you use Sitecore JSS star as the namespace that you pass to the debug variable. But again, you can get more granular. You can see just layout service calls and dictionary service calls, for example. Or if you're using Headless SXA, they've got filters for the sitemap service, robot service. If you're using CDP or personalized, there are filters just for those. So it's really up to you. You can decide what you want to show and focus on. You can also turn on debug logging in the browser to see some of these logs come through in the browser console. And the way that you do that is not through the .env file, but instead you have to go to the browser console and set the debug property on local storage. So when you do this, what'll happen is any calls that are made in the client triggering one of those filters will show up in the DevTools console like this. I do want to note that most everything that you do in a Next.js application out of the box is done on the server. So if you turn this on, like on a fresh application, you're not going to see any logs, and that's perfectly normal. We're going to look at how to turn those on for client-side requests here in a minute. So to recap, you can enable debug logging for the server in your .env file, set debug multi-line equals true for better readability. You can enable debug logging for the browser by setting the debug property on local storage in your browser console. And you can actually create your own namespaces. So if you want to create application-specific namespaces to use with debug, you can do that by using this debug function. And you can go and check out this URL here to find out how to create your own namespaces. And then Sitecore's also got some really good documentation on that as well. So check out both of these URLs. All right, for tip number 2, we'll look at the data fetchers provided by JSS. The Sitecore JSS library exports 3 data fetchers that you can use in your application. There's the native data fetcher, which wraps fetch. There's the Axios data fetcher, which wraps Axios. And then there's the GraphQL request client, which is intended for making GraphQL calls against the Sitecore APIs. The GraphQL request client, it's really nice because it will handle rate limiting, like against the experience edge, and it also has retry logic in there for any errors that might happen. So yeah, you'll use that for Sitecore API calls, but for just general API calls, I'll say if you like Axios and you've got a really good reason to use it, you can use the Axios data fetcher, but more than likely, I recommend you use the native data fetcher, which wraps fetch. The reason for that is that Next.js ships with its own implementation of fetch, and Vercel is constantly adding features to fetch, like request deduplication and caching. And so if you use the native data fetcher, you'll get those features for free, whereas you wouldn't get those with the Axios data fetcher. The nice thing about using these is they all are configured to use debug logging. So you'll get that feature for free when you use these. They're quite easy to use. So if you want to use the native data fetcher, you just import it from the Sitecore JSS Next.js library like this. And then the API is very similar to using just a regular fetch. Like you can call the catfact API like I've done here and get some data back. And again, this will trigger that debug logging that I showed in the first tip. To see the debug logging that it triggers, you would just turn on the HTTP filter and again, set debug multi-line equals to true in your env file. And once you do that, anytime you use the native data fetcher or the GraphQL request client in your server console, you'll start seeing requests and responses get logged. If you use the native data fetcher or GraphQL request client in the client, like in a component, if you use it in a use effect hook, for example, you can see logs for that in the browser console by setting that debug property, as I've shown here, on local storage. And then that will actually trigger some debug logging in the browser to happen. So to recap, use the native data fetcher instead of fetch. You can use the Axios data fetcher instead of Axios, but I don't recommend that really unless you've got a super good reason. When you're calling the Sitecore GraphQL APIs, use the GraphQL request client. And the nice thing about these is you can use them with debug logging for diagnostics. Okay, tip number 3, we'll look at the component level data fetching feature that ships with the Sitecore JSS Next.js SDK. So we'll start by looking at a typical data fetching scenario in a React component. So this React component, it's pretty simple. All it's doing is going off and calling the catfact API. while the CatFact API is loading, it'll show a loading message. And once the API returns data, it'll show the fact that comes back from the API. In a React component, anytime you want to do this, you've probably seen this pattern. You're going to use state to declare some state, like I've shown here. And then you'll use the use effect hook to actually make your API call. And once the API call completes, you'll set the state, and that will trigger a re-render of your component. While your state is null, you don't have the data back from the API, you can show a loader, and then once it's complete, you can actually show the data from the API. The problem with this is use effect, though, because use effect only executes on the client. It doesn't execute during server-side rendering. The result is that if you set up a loader like I showed before, you can imagine if I've got that component 4 times on the page, what's going to happen is you're going to see a flash of content as that API call is made in the client. It's not the best user experience, and it can have negative impacts on SEO for your site. And the cool thing is, if you're working in just a standard React app, there wasn't really a good solution for this, but Next.js does have a solution at the page level, and that comes in the form of 2 functions. One's called get static props, and the other is get server-side props. So if your application is using static site generation, you would use get static props. If you're using server-side rendering or SSR, you would use the get server-side props. And the way that you use those in a standard Next.js application, kind of taking JSS out of the picture here, is at the page level, alongside your page, you would export one of those 2 functions. So again, if you're using SSG, you would export this get static props function. And what this will do is during SSG of your pages, it'll execute this function, and you can do things like make API calls, or you can do computationally intensive tasks. So in this case, I'm just making a fetch call. And once I get done with that, I can return from my function whatever data I want. And what Next.js will do is it'll take whatever you return from this and pass it as a prop to your page. And from that point, at the page level, you can start drilling that prop down to the components that the page is going to render. And this is a really cool feature in Next.js, but it's got one problem when you're working with Sitecore. So in a standard Next.js application, your pages are usually going to be static, and you know ahead of time what components are going to render on the page. So if you consider I've got like a component here, or a page that's rendering 4 components in a standard Next.js application, if all 4 of those components need data from an API, I've got to go and request all of the data for those components at the page level like this. And that's okay. But the problem is, in a Sitecore application, we don't know ahead of time what components are going to get rendered. The content authors decide that. So it doesn't make sense if we've got 100 components in our library available to content authors to make 100 API calls at the page level. And the Sitecore JSS team has implemented a really cool feature in the Next.js SDK that helps us work around this. And that takes the form of exporting these get server-side props and get static props functions, not at the page level, but at the component level. So if we go back and look at our component from before, where we're using use state and use effect to make API calls on the client, we can easily refactor this using component level data fetching to make these calls on the server instead. And it's as simple as this. Just alongside your components, you export get static props or get server-side props. Inside of that, make your API call or do something that's heavily intensive, computationally intensive, and then return that data when you're done. And the JSS SDK is going to pass whatever data you return from this function to your component, and you can use it like a regular prop. You can notice, since we're doing this on the server during server-side rendering or during static site generation, we don't need a loader because this is going to be part of the HTML that's returned up to the client initially. And this is nice. It solves that SEO issue, the flash of content. And so, yeah, like on this, you can imagine with that refactored component, there's no animation needed here because the HTML is going to have the data, the API data supplied during server-side rendering. There's one thing to be careful of though. If you are using on your project JSS 21.6.4, the client libraries, you don't have to worry about what I'm about to say. But if you're using an earlier version of JSS, be very careful when using these features. So JSS has a bug around this that can be a security problem for you. In a vanilla Next.js application, the page level get static props and get server side props are excluded from the client bundle. And that makes sense, right? This is code that's only going to execute on the server. There's no reason to ship that up to the browser. Vercel in their documentation even says, because of that, you can put connection strings in these functions. You can put API secrets, anything, that's fine. It's your server code. It's not going to go to the browser. However, the component level get static props and get server side props. They're not excluded from the client bundle. Again, this is a special feature for JSS. And so if you're on a version prior to 21.6.4, you need to make sure that you never put any kind of sensitive data in either of those component level data functions. Because if you do, if you put a connection string in there, you put a password or an API secret, when someone comes to your site, that's going to be present in the JavaScript that gets sent to their browser, and those things will get exposed. So just be careful, be aware of that if you're on an older version. And I think if you keep that in mind, these functions still have a lot of value. So to recap, you can use get static props and get server side props in your components in a JSS application. If it's possible, upgrade your JSS libraries to 21.6.4 or higher today. Don't delay. But if you can't upgrade, then just keep in mind that bug and don't put sensitive data in those functions. Here's some further reading. You can go and see the release where the JSS team fixed that issue on the first link there. I actually reported this to the JSS team last year. Came across it while I was working on this presentation, actually. So if you want to see that issue that I opened up and where they fixed it, you can see that there. Sitecore's got some really good documentation on the component level data fetching, and Vercel has really good documentation on the page level data fetching that ships with Next.js. So check out those links. All right, so we just spent a good amount of time looking at ways to do data fetching at the server level, but there's still going to be a lot of scenarios where you want to do data fetching in the client. And so for this tip, I want to focus on a library called SWR that supercharges data fetching in the client. So again, looking at our content block, our cat fact example from before, in a React component, anytime you want to make a client-side API call, you're going to use that combo of the useState and useEffect hook. Use the useState hook to declare some state. Inside of useEffect, make your data fetching. Once the data fetching is complete, set the state. Then this will trigger a re-render of your component. While the API call is executing, show a loader maybe, and then once it's finished, show your data. This is a pretty standard pattern, but it's kind of kludgy having to use two hooks like this. And so there's a really nice library called SWR that makes this a lot simpler. SWR stands for stale while revalidate. And this is a library that's developed by Vercel. So that's the same team that makes Next.js. So it integrates really nicely with Next.js applications. So let's take a look at how you can use SWR instead of that two hook combo to make client-side calls. So looking at our component again here, instead of using the useState and useEffect hooks, instead you can use just one hook called useSWR. The first thing that you do is you pass a URL to it like this. So just pass the cat fact API URL. And the second thing that you pass to it is a fetcher function. And this just tells SWR, hey, for any URL, this is how I want you to go retrieve that data. behind the scenes, SWR will handle that use state, use effect stuff for you. And it returns a whole bunch of parameters that you can use that are really easy to understand. The first one is a Boolean called isLoading. This just returns true while the API call is executing, otherwise it returns false. If an error occurs, it returns an error property. And then of course you get your data back in this data property. And yeah, then instead of like looking at null state or some other weird stuff, you can just look at the loading property to decide whether or not to show your loader, and then otherwise show you the data that you get back from the API. I think this is a lot cleaner than having to use two hooks every time you want to make an API call. But it doesn't just give you cleaner code. SWR has a whole bunch of really neat features. So it can do auto refetching and request deduplication, which we'll look at in a second. It can set up dependent queries very easily. So if you've got like a query that requires another query to execute before it, that's easy to configure. It'll do prefetching and caching for you. It can handle pagination and infinite scroll, and it comes with TypeScript support out of the box. It's pretty neat. Let's take a look at two of the features that you get for free as soon as you start using that hook. You don't even have to do anything for these to start working. So here I've got a page that's got that cat fact component on it 4 times. So the component's on there individually 4 times. And what I'm doing here is I'm just clicking in and out of the browser. Every time you do that, SWR will see that the browser is losing and gaining focus, and it'll just go make the API call for you automatically. So that's pretty neat. As soon as you start using this hook, you'll notice this because you'll be like, hey, why does it seem like my page is refreshing? And it's SWR doing that for you. The other thing that SWR is doing here that's pretty cool is request deduplication. So if I were using that use state and use effect combo on these components, each one of these cat fact components would actually be getting a different fact back from the API, right? Because each component is going to make that API call separately. However, SWR is smart enough to see, hey, I'm making an API call 4 times. Let me just grab the response from the first one and share that across all 4 of the components. So this request deduplication will improve the performance of your site. It won't make 4 calls, it'll just make 1 instead. And that's pretty neat. Again, you don't even have to do anything for that to work. You just get that for free when you use that hook. The other nice thing is that since to SWR, you're providing a generic fetcher function, instead of just using like a standard fetch, you can use those fetching functions that I told you about earlier and get the debug logging for free, right? So here, instead of using fetch, I'm using the native data fetcher, and you just pass that to SWR. And then when you do this, anytime SWR executes in the browser, if you've got debug logging turned on, you'll see your requests and your responses get logged to the browser console from SWR. So that's pretty neat. Another thing that's really cool about SWR is they have a browser extension called SWR DevTools. And you can use this to inspect the SWR cache in your application. You can see the history and see network calls as they're being made. So to recap, SWR, it simplifies and supercharges your data fetching code, but it's actually not the only game in town. There's an alternative to SWR called React Query, developed by a team, a separate team from Vercel, that's got a very similar feature set. And I highly recommend, if you've not used either of these, to go check them both out before landing on one to use in your application. So here's the URL to see SWR and the dev tools. And if you're interested in React Query, there's the URL for that as well. And I highly recommend that. I've used React Query on projects before and had great success. All right, so for this tip, we are actually going to kind of combine the last two, the component level data fetching with SWR, to look at how you can provide mock data really cleanly in Experience Editor and Pages. So when you're developing a Sitecore application, you're really developing two applications, right? You're developing the application for your end users, but you've also got to develop the layout building experience in Pages and the experience editor, and that often requires separate code. Something that I advocate when developing for Pages in the experience editor is that these tools are for designing layouts. They are not for testing your APIs. So your components really shouldn't ever be making API calls in Pages in the experience editor. All they should be doing in Pages in the experience editor is just showing mock data, some kind of representative data to give your content authors an idea of how the component is going to actually look when it renders on the page for your end users. The biggest reason for this is that React re-renders and any kind of client-side rendering can break the experience editor. Experience editor being built on server-side rendering technologies many years ago is very sensitive to client-side rendering. So if we look back at our content block example from before, I've refactored this a little bit, and what I've got is while the API call is executing, we're showing a loader. But once the API call finishes, what we're going to do is show the API data, but also show a field helper, like maybe show an image field from Sitecore and render a placeholder. If you do this, if you have conditional renderings of field helpers or placeholders, you're going to break the experience editor for sure. The issues that you'll see is that inline editing won't work. When you first go and insert a component into the experience editor that's got this kind of conditional rendering, it won't render. Or placeholders that you have in this kind of scenario won't work either. You'll see this error message when you try to put a component in that placeholder, it'll say could not find the rendering in the HTML loaded from the server. And there's a whole other list of things that can happen, but these are the big ones. So what I'd like to show now is a way that we can use SWR and component level data fetching to provide mock data and not have these issues at all. So here's our component. We're using SWR to go and get some data back from the CatFact API, and we show a loader while that data is loading. We can refactor this to use SWR and component level data fetching to easily return mock data, and it looks like this. Now, I know this looks like a lot of code, but we can break it down and it's not too bad. The first thing we've got is we've got our component level fetching function, get server side props, or it could be get static props, it doesn't matter. And inside of this, the first thing we check is, are we in the experience editor? If we're in the experience editor, then we'll do some work. But if we're not in the experience editor, don't return anything because we don't want the normal user flows to be affected. But when we are in the experience editor, for example, we can do something as simple as just return an object that's got some editing data, just some representative data like this. Like I said before, what'll happen is this will get passed as a prop down to your component, and then you can take advantage of a really cool SWR feature called fallback data. So what we're doing here is we're just telling SWR, use this editing data as fallback data. What SWR will do is while it's executing the API call and that API call is loading, it'll return your fallback data instead. So yeah, this is a really nice way to provide mock data, but you've still got a problem. So like I said, it's only going to return this data while the API call is executing. But once that API call finishes, it's still going to refresh your component and get the real data. So the next step is we've got to turn off those API calls. SWR makes that pretty easy too. The way that you do that is you would go to your page, for example, your Sitecore page, and declare an SWR config element like this. On your SWR config element, you tell it, do not do revalidate on focus or revalidate on mount when we're in the editor. And basically what this tells SWR is when we're in the experience editor, just use the fallback data. Don't ever make API calls. And so that's quite nice, right? Now in the experience editor and pages, yeah, you can always count on mock data getting served up and your API calls not executing. Another nice thing about this approach is since you're returning your mock data from those component level data fetching functions, if you're on JSS 21.6.4 or later, that data is not going to get included in the client bundle. So you don't have to worry about your client bundle getting unnecessarily bloated with mock data that the end users are never going to see. The build system will take that out for you automatically. So I think that's pretty cool. All right, to recap, don't call APIs in Pages or the experience editor, because client-side rendering of the JSS field helpers and placeholders will break the experience editor. You can use get static props and get server-side props in components to return mock data, and then pass that to use SWR's fallback data to get it to return that instead of API calls. Lastly, turn off revalidate on mount and revalidate on focus when you're in Pages in the experience editor, and you don't have to worry about API calls executing. Okay, that's enough about data fetching. We're not going to talk about that anymore. We'll have an easy tip now, and this one is always define a root element. This is another one for Pages in the experience editor. I see this pretty often in a React component. Instead of there being a real root element, like a div or a span, you'll see just a React fragment return like this. If you do this, the experience editor and Pages won't work properly for this component. And this actually isn't a problem for Next.js only. This problem goes all the way back to XSLT, web forms, MVC. It doesn't matter. If your component doesn't have a real root element, it's going to cause issues. So don't do this. Styles will get broken in the experience editor and Pages. Inline field editing won't work properly on insert, and placeholders won't work properly if you do that. So just make sure in your components that they always have a single real root element, like a div or a span. Doesn't matter, just don't let it be a fragment. And your components will always work. Your content authors will be happy. Something that might be interesting to develop for the community would be an ESLint or a prettier plugin that detects this issue, because I'm sure that this can be statically analyzed. The next tip is pretty easy as well. This is about disabling Next.js telemetry. So if privacy is a concern for you or your clients, you want to set this in your .env file. Next telemetry disabled equals 1. Vercel is constantly collecting telemetry from your Next.js server to get better feedback on their features and what they should develop in the future. But a lot of people don't want telemetry captured on their servers. So set this, check it in the source control, and you're done. You don't have to worry about Next.js telemetry anymore. Sitecore's got a bit of documentation on it that you can see here, and Vercel's got documentation on it as well. There are other ways to turn it off, but that's by far the easiest one, I think. Okay, our next tip is looking at a way to make your Next.js SDK upgrades a bit easier. And that's using a feature from JSS called config plugins. So in the root of your Next.js application, there's a Next config.js where you can configure all of Next settings. A new Sitecore JSS application has a whole bunch of stuff configured there already. And it's a pretty big list of things. This isn't exhaustive by any means, but you can set up things like the Next.js distribution directory, environment variables, headers, redirects, rewrites, webpack config. But modifying these things directly in your Next config.js can make your upgrades more difficult. So there's actually a really clean way to pull these changes out of your Next config.js and put them in individual files, and that's through config plugins. Every Next.js app from Sitecore ships with some config plugins by default, and you can find them under the folder here, the Next config plugins folder. And this is the general shape of a config plugin. So instead of modifying the Next.js config directly, you just set your Next.js config settings here. And at build time, these config plugins get applied to the Next.js config. If you're coming from the .NET world, this is really similar to Sitecore config patches and web config transforms. So let's look at a really simple example. Say you wanted to set the powered by header to false. You just create a new file called poweredbyheader.js in the plugins folder. Inside of it, set powered by header to false. And then the next time you build your application, this will get merged into the Next.js config. And yeah, the powered by header won't show up anymore. So admittedly, this is a pretty simple example, but these config plugins can get pretty big pretty quickly. Imagine that you've got a feature that requires rewrites and redirects and other like Webpack configs. If you go and put that in the next config directly, they're all gonna those little pieces of your feature are gonna get strewn about all over the place. But with these config plugins, you can have a single file dedicated to your feature that's got all of those mutations to the next config kept tidily together. Just remember that anytime you create or change a next config plugin, you've got to rebuild. So run JSS start, or if you're using Docker, restart your rendering host. And to recap, I recommend don't edit Next.js config directly. Instead, create plugins to make modifications, and then always remember to rebuild the app after you create or modify a plugin. All right, tip number 9. This tip will help you get a better understanding of your website payloads. So Next.js has a bundle analyzer feature that you can install very easily. Just do npm install next bundle analyzer like this. This will install the necessary node modules, and then you create a config plugin. It looks just like this. Drop it into your plugins folder, and from your config plugin, you're going to return this with bundle analyzer function and set a couple of things. The first thing that you'll want to set is tell bundle analyzer that it should be enabled when the analyze environment variable is true. And the second thing is to set this open analyzer setting to false. If you set open analyzer to true, every time you save your application, a new tab is going to open in your browser for the bundle analyzer, and you'll quickly get like 1,000 tabs, and it's not very helpful. So I recommend just set that to false out of the gate. Once you've configured your config plugin like this, then go into your .env file, set analyze to true, and then the next time you build and run your application, bundle analyzer will output a couple of files, one for your client bundle at that client HTML path, and one for your server bundle at that node.js.html path. When you open up those pages, this is what it'll look like. So the client HTML file is going to show you all of the different chunks that are sent up to the browser. So you'll see main, you'll see one for each of your pages, like the 404 page. You'll see one for the slugs that you've got configured like this, and then you'll see one for the app. You'll notice that node modules makes up the bulk of each of these chunks out of the box. And aside from node modules, you can see the components that get included for each of those pages. But I know this is kind of hard to see. So there's a nice sidebar hidden off to the side that you can open up. And from this sidebar, you can actually choose to focus on specific chunks. So if you wanted to look at just your page slug, you can do that and you'll actually zoom in. And again, you can see that node modules is taking up the majority of space in this chunk. You can even see all the Sitecore JSS libraries right there. They probably take up about 1/4 of the node modules folder in a stock application. And then over here on the right, here are all the components that are getting included in that chunk. So that's what the client file looks like. The server one actually looks a little bit different. So if you open up the bundle analyzer for the server, one of the things that you'll notice on each of your chunks is that they've got a document.js file in them that you didn't see in the client. The reason for that is the document.js file is only going to execute on the server, so it doesn't get built and included in the client bundle. But yeah, there's a lot of other stuff, like you see node modules is much smaller here than it is in the client bundle. So really handy tool for kind of figuring out what's going on with your bundle, your bundle sizes that are getting sent up to the client. You can use it to find code that doesn't belong in the client, and you can enable it easily with a config plugin. Some really good documentation about it here. Check out that URL. All right, our final tip is probably my favorite one, and it's about a node module called patch package. Pretty simple what it does. It lets you patch node modules. So if you ever had a case where you needed to modify something in a node modules folder, patch package will let you do that and then share that change, keep that change in your repo and share it with other people on your team, and even deploy that change to production. To use it, just install patch package with npm like this. And then in your package JSON, you will add a post install script. And yeah, you just give it the patch package command. And what this does is it says, after you run npm install, always run your patches through patch package. And this will make sure that your changes get applied to the node modules folder. So let's look at how you can use it. A node module that's going to get included in almost every project is even. And what you would do is you would just open up the is-even index.js, for example, in your favorite code editor, and you start making a change to it. So in this case, again, we're working straight in the node modules folder. Go and we're changing the is-even function to always return true on Mondays. If you, for whatever reason, want to share this with your team, you make that change in your node modules folder, and then switch over to your terminal and run this command right here. You run npx patch package and give it the name of the module that you modified. When you run this command, what patch package is going to do, it's going to run off. It's going to get a clean copy of that package that you modified, and it's going to diff it against your node modules folder. And from that diff, it'll create a patch file and put that in your repo. Then from that point, something that I recommend you always do is it's going to give you a command to go and create an issue on the repo for that module. Please do this. If you ever have to modify node modules, for example, to include extra exports, for example, anything, you should let the package maintainers know so that they can go and patch this in and make it available upstream for others. But once you've done that, you've got your patch. The patch is going to get created in the patches folder of your repo for you. It's going to automatically have a name generated, and it'll look like this. It just looks like a git patch. You check this into source control. Then next time anybody runs npm install from your repo, patch package will run automatically after npm install, and it'll apply those patches to the node modules folder as shown here. I warn you, use this sparingly. It can feel like this is something that you should jump to anytime you run into a problem in node modules. I'm not saying that you should do that. However, there are cases like, say you want to get that that fix for the component level data fetching functions in your application, but for whatever reason you can't upgrade to JSS 21.6.4. You could use patch package to backport that fix into your repo without having to upgrade to JSS. So it's a really nice tool to have in your tool belt for situations like that. So to recap, use patch package to modify node modules. Any patches that you create are going to get put in the patches folder of your repo. Please, if you do use it, submit issues to the package maintainers and use this sparingly. Really good documentation about this here at this link. And yeah, that's it.